Uh,
Yes, go ahead.
yeah, sure. Thanks. So before I begin, I'll just highlight whatever we're going to do in this session, like a three-part agenda, basically. So first, I'll go over the use cases of cloud computing, like where do you actually employ the services of the cloud in your daily life, in your practical applications. Then I'm going to talk about the 30-day programming specifics, like what this program is, what the tracks are, what do the quests mean, and what do you gain out of it. And after we're done with that, I'll just go over maybe one of the labs and I'll just share a few general tips on how to approach labs, how to go about solving them, and so that you have a better knowledge so that you don't get stuck in like common trivial problems. And whenever you're stuck, you know how to debug and whom to reach out to in order to resolve your doubts. So we'll just begin quickly. I'll go over to the slide. I'll just share my screen. Give me a second. Yeah, I hope you can now see my screen.
It's perfect.
Yeah, sure. Thanks. So let's go ahead. So first, a slight introduction about myself. I'm Jayesh, and I like working on the cloud. And I've been fascinated about the technologies that are associated with it for a very long time now. And I've explored a lot of different options online, and I'm sure I'm going to talk about them today and try to give you some enthusiasm about all the technologies and what you can achieve using them. And yeah, so I'm also with the Master Student Ambassador program. So yeah, we will also talk about that in a few minutes. Maybe about Azure and other things. I'll just compare GCP and Azure for a short while. And apart from that, I have also worked on CNCF's Cloud Data Computing Foundation's computer program for the CodeNS organization. So there I worked on Kubernetes and other related software. So I have some practical knowledge about how to apply all these skills in real life and how do people in the industry use cloud technologies and what potential does it hold for us as students. So I'd like to share all of that in the next slides. So before moving on, I'll just share a very old slide which I made for introduction to cloud computing. And the purpose of this is getting you up to speed with what cloud computing actually is and where do you actually use cloud computing. So let's go over to that. Yeah. So I'll use a very common use case which you can relate to, and then we'll see where the cloud comes in, like what is the actual value of cloud. So yeah, first we talk about servers, and I'll just give you a very short example of what servers are and how do servers, what role do servers play in the application that you build. And when you understand what a server is and how it's run, then you can maybe relate it better to how you're going to use the cloud to host a server. So first of all, we'll just talk about the architecture of a server. Like this is the diagram of the server. So it starts from here, from the view part, and then goes up to the database part. So there are different layers of a server. So what does the view do? The view is what you see, like on your mobile phone, your application or desktop application, that forms a part of the view. So this is what is being served to the end user. This is the first part of the entire architecture. When you go ahead, you have the controller part. So the controller is part of the backend. So what happens is whenever you open an app and you click on some service, it sends a request to the server and backend, and the controller is the first point of contact, which then passes your request and then forwards it to particular sections within your server. So a controller has to decide that this request has to go to this particular part of the program which is going to solve it. Right? It just deviates it to different functions. And then comes your service layers. The service layers are the most important layers because they contain a business logic, like entire logic between like if you're searching for restaurants online, then this layer will decide whether the restaurant is open at this point or not, whether it's close to you within the given distance or range or not. So this part holds all the logic. In what order do you want to sort the restaurant list? So all of that logic will come into the repositories and the domain logic layer. The final layer, which is it's a database layer, I'm not mentioning it here. So it is called the repository layer. So it holds all your data. Like it doesn't do any operations except for just CRUD operations, create, read, update, and delete. And all of that is handled by the services itself. And model is just the thing which you pass on. Like if I talk about the model in this case, it will be a restaurant class. So you just keep on passing that restaurants across the different services, across the different layers. So this is part of the model. So this entire architecture is called the MVCS architecture, the Model View Controller Service Architecture. So just a very basic idea of how a server looks like and a very basic function of what it does in the background. Now I'll give you a very practical example of it. So imagine you have a food servicing app like Zomato or Swiggy. So what do you think happens when you click on the app and place an order? Like maybe I can monitor the chats if I'm not wrong. Let me see. Uh, just go over to the chats and see if if there are people who want to respond to this. Like, what is your idea of what happens when you click on, say, if you order something on a food ordering app? Like, what are the first steps that go on within the app? Does anybody want to respond to this? I'll wait for a couple of minutes and see if you have some responses. Like, I'm trying to getting this engagement more productive because I'm not able to see you guys. So I'm not sure whether you're getting this idea or not. So if you have any slight idea of what happens in the background, it's really helpful. But I'll still go over it again, obviously. I don't see any responses yet, so maybe I'll just go over. Yep. I'll do this again. Yeah, so when you open the app, as I just explained, what happens is it sends a request to Zomato's servers, and the controller there will identify what kind of request you have. Like if I want a get restaurants request, then the controller will identify that and then send a request to that particular part of the function. The next slide here shows you a very slight idea of what this function will look like. Like it should have a get mapping. So it will be able, this is a part of the controller actually. So this will identify that your request is a get request and it wants a menu. So it will just forward this particular request to that function in the services there. So if you can see, it is calling that menu service here. So menu service is a part where all your logic is for the menu part, for the menu model. So whenever you do a get menu call, it will send your request to the find menu function inside the menu service. So this is how a controller transfers control of a program to different parts of the service. So this is very basic. And you can ignore all the different jargon in this part. I just wanted to show you how it actually looks like. Yeah, so now we come to the actual part, like how do you host the server? Like you'll have some machine somewhere which will be having this particular software and you'll be listening to requests that your clients make. So a very primitive idea would be you can purchase some hardware. You can maybe buy 2 or 3 computers and then install the software and make them accessible to the internet. And then you can start your service. You can launch your app. But obviously, you'll have a few things to consider in this case. Say, for example, your app has to be available throughout the entire day. So you have to keep your machines running throughout the day. Is the first consideration. The second thing which you have to consider is the scalability. What happens, say, for example, during dinner or lunch, that the usage of your app spikes. So you have a lot more traffic coming in than what you anticipated. So in that case, you might feel like you will have to add more systems in order to improve user experience. Because if you have a lot of users and you have very less machines, then each request will take a lot of time. So you'll have to, invest more in other machines, buying more machines and all those things. But can you think of any policy to this? Like, what disadvantage do we have if I invest more in buying more machines? So if you think about it, one very obvious downside to this is your traffic surge might not persist for long. For example, I might have only very high traffic during lunch and not at other times. So what I'm investing in my resources is getting wasted for a majority of the time period. For example, maybe I'll have a very high spike for 2 hours in the lunchtime and 2 hours in dinner time. So I'm actually investing a lot in buying machines, but these machines are not being used throughout the day except for 4 hours. So this is a waste of my resources and waste of my energy. So how do you combat this particular situation? So this is where you leverage the power of the cloud. So cloud, what does cloud do? So you can imagine that these are services, these are machines which are maintained by different giants. For example, you have Microsoft Azure, you have AWS, Google Cloud, and DigitalOcean. So all of these actually are servers which are hosted by these companies, and they make these things available to you. So so you don't have to manage the entire computer's physical systems yourselves. and what do these things offer. So I just first I'll go over a very workflow of what you would do in such a case of deploying a server. So the first thing would be you create a virtual machine hosted on the remote servers. Like you'll hire a virtual machine, you'll go over there and you'll ask Google to give you a virtual machine. You also, maybe most of you had completed the first lab, so you will know what a virtual machine is and how do you create one. And so what does a virtual machine actually do? It's just a simple computer system which is rented to you by Google. So you'll take a virtual machine from Google, you then install all technologies that you want. Like you can install your, say if you have a Java application, you install Java on it. You'll install other different libraries that you require in that case. And then you'll just run the program. So your server is up and running on Google's machines. So that is the idea of how it works initially. And yeah, there are containerization and other techniques which simplify these processes. But maybe we'll talk about them in a very different, maybe another workshop or sometime. I'll talk about what the benefits are in such a case. So say for example, you want to change specifications, you want to upgrade the RAM of your system, or you want some more storage for this. So you can always do that without affecting your service. Like you can also request more service, so it will keep on running your original application in the same day, and it will provision new resources at the same time. So this is one of the benefits. So you don't have to worry about downtimes. And then you can also replicate, you can scale up and scale down your resources. So if you have a surge in traffic, you can just ask them to scale up. It all happens automatically. And when the traffic dies down, you can just revert back to your original value, original quantities. And yeah, and you can also prevent overloading of any particular instance using load balancers. So all of these systems also offer different ways to control how much information goes to each instance. So you don't overload a particular machine with lots of requests. So these are some of the benefits that are already given to you by the different cloud providers. You don't have to work on them yourself. So you just get them out of the box. Yeah, Kubernetes. Kubernetes is one of the things which helps in orchestrating all of these distributed systems in a much easier way. So yeah, we'll talk about that in maybe another workshop as soon as we'll plan another workshop for this. Because Kubernetes is really essential in cloud computing, because almost every other company which is working on distributed systems uses Kubernetes. So just to give you a very short introduction to Kubernetes, it is nothing but a software which can automate what different machines will run what applications. For example, if you have a single application that you want to run across multiple machines. So how do you decide that which part of the application should run on what machine and for how long, and what scheduling should be done? So all of this thing is automated by Kubernetes itself. So you just tell Kubernetes that, see, this is the application and I want this to be available for this much time and in these regions. So Kubernetes will automatically identify on what computers to deploy your application. And so this is a really helpful thing when you deploy applications on a large scale. So yeah, we'll talk about that later on, maybe. Yeah, so just to conclude, so we have understood how applications works, what servers look like, and what benefits do the cloud computing offers to you as a application owner, as a business owner. Yeah, so we're done with that. Now I'll proceed to the Google Cloud program. And before I do that, I'll just go over another use case, a very common and fun use case. So you're all familiar with PUBG, right? So how do you think PUBG works? So initially, say for example, you're the developer of this game. Now you had an initial idea that, okay, maybe 1,000 people are going to play my game in the first month. Now, say for example, you go to bed and you wake up the next day and you see that your app has gone really viral and you have 100x or more of the traffic that you initially intended to have. So how do you handle that? So it's just another use case which I already mentioned to you before. So in this case as well, what you'll do is, instead of buying new hardware, you can just transfer all of that thing to the cloud. And in that case, the cloud will scale automatically and will help you get on with your application, and you don't have to have a bad user experience in your app. So this is the entire thing. I'm just going over that again, the same thing. And moreover, most of the things offer a policy of pay as you go. So you only have to pay for what you're going to use. Like if you're not using a particular resource, the Microsoft, Google, they won't ask you to pay for it. So it's very efficient in terms of the costs. Yeah, and uptime availability, obviously. So you have a very nice uptime, because there are engineers working around the clock to make sure that your instances are up and they don't go down. You also have some control over it yourself. You can monitor your instances yourself, but in most of the cases, they ensure that none of the systems go down in a very, and if they go down, they can always replicate it somewhere else. So you don't have to worry about your service being down if you're deploying with these services. Yeah. So now I'll come to Google Cloud. So so you know that Google Cloud can do all of these amazing things. So I like to divide these things into three different parts so you can understand it more logically. So when I talk about virtual machines, when I talk about cloud functions, you must have heard these terms, right? So how do you classify them into, like, how do you understand the entire structure of these things? So first I'll talk about these three different things. So the services offered by a cloud service, not Google Cloud alone, you can also talk about AWS, Azure, all of them are the same thing. So the services can be divided into three different parts. The first thing is infrastructure as a service, the second is platform as a service, and third is a software as a service. I'll go over each of them. So first is infrastructure as a service. So this means that when you are talking about this particular case, it means raw computing power. For example, if I want a computer, if I want some RAM, some storage, and some like compute power, I'll just go over to Google and ask them to give me that. For example, virtual machine is an example of infrastructure as a service. So I'll just go over, I'll provision a machine for myself, and that machine will be raw. It won't have any software installed on it. It will just be pure computing power. I'll have this much CPU, this much RAM, and maybe I'll provision this much storage, persistent storage for it. So this is all I get. And on top of that, I'll have to build everything myself. I'll have to install some software. I'll have to make sure that the operating system on this machine is up to date, and everything else I have to manage myself and only get the hardware part from Google. So this comprises the infrastructure as a service part. So whenever you're going to make a virtual machine and you select whatever operating system you use, you'll have to make sure that you update, you patch, and all of these things you have to take care of yourselves. So it also has some use cases. For example, companies which are having some broad applications prefer to use virtual machines because they can have more control over the software that is running on the machines. So it also has some use cases, but generally for students, we don't think that virtual machines will be a best choice because you have to manage the networking yourself as well. You have to configure load balancers, and there's a lot of stuff that goes behind, configuring a virtual machine on its own. So this is the first thing, the infrastructure as a service. The second is platform as a service. It is taking the infrastructure as a service and then putting some things on top of it. So platform as a service usually has, so it allows you to just run the application. Just think about the application you're going to run. For example, if I have a Java application, I'll just worry about the Java application itself. I won't worry about the machine that is running it. For example, the machine will be pre-configured. The networking will be done. The load balances will be configured, and even Java will be pre-installed on the application on the machine. So I just have to load my application into that machine and allow it to run. So platform as a service is a much more practical option. It does take care of a lot of things on its own, and you just have to worry about the application and the actual logic which you write. So it's actually very nice for developers who don't have like a good background in DevOps and who don't understand a lot of management and all those things. So platform as a service is really good. An example of this could be a Google App Engine. So for Google App Engine, you can always leverage the benefits of notification or other different things, and you just have to work on your particular app. The third thing is software as a service. So software as a service is a complete managed solution for your application. For example, you can take Gmail as an example. You use Gmail, right? You go to the Gmail, you write emails to other people. You don't have to worry about what machine Gmail is running on or what software is running in the background. You just use the service itself. So that is what is meant by software as a service. So if you employ software as a service, you don't have to worry about anything at all. You just have to use the service and you can just provide it as it is to your clients. So this is the third part, is called software as a service. So I hope you understand and you have a better picture now of how cloud services are divided into three different parts logically, and how you can go about thinking about what solution fits best for you. So whenever you are approached by a problem, you have to first think about what kind of resources do you want. Do you want a virtual machine, or do you want an app engine, or do you want a software? So when you think about that, you can then proceed to these three different sections and then go about choosing your resources accordingly. Yeah, now I'll talk about the program itself. Yeah, so this is a program in a nutshell. So you have two tracks, which I'm going to talk about in the next slides. So the first is a cloud engineering track, and the second is a data science and machine learning track. And so these tracks are, okay, we'll talk about them in the next slides. Don't worry about that. And then you have to complete one of these tracks, or you can complete both of them. You get recognized for your efforts, you get certificates, and you get other swag, which I'll discuss. And then you also get some skill badges. And I'll tell you about the importance of skill badges in the next slides and really important things. Yeah. So the first track, the cloud engineering part. Now I would like you to think that since the cloud computing is actually very broad domain, so you have to. I think these quests do a very good job in making you understand the entire scenario. So what I'll just break down the entire structure of these things. So a track has different quests. So what you see on the screen here, the 6 things, these are quests. A quest has different labs on its own. So the first quest will have, I say, maybe 4 or 5 labs, and I'm going to remember the number. So every quest will have a lab. The quest itself is like a logical grouping. So, say for example, the take the example of the sixth quest, deploy to Kubernetes in Google Cloud. So this quest will have different labs which will get you familiar with what Kubernetes is, how Kubernetes works, how Kubernetes networking does. So the sixth quest will cover all the labs, and if you do all the labs, you'll have a good understanding of Kubernetes is. So the purpose of these quests is to get you familiar with the different services that are offered to Google Cloud and gets you a hand-on experience with the different services. So the possibilities are endless with these things. So if you have to work on, say, for example, edge computing, if you have heard about edge computing, so this can also be cloud in this case, IoT, and all these things everything is ultimately related to the cloud. So if you have a good understanding of how to provision resources and how to go about using them, you can practically apply it any application that you build. For any solution that you build, you can always, migrate it to the cloud for a better experience. And so if you look at it, they'll have different quests, and all the links I've shared in the Discord channel as well. If you go to my Discord channel, it's under the programming section, and it'll have a lot of pinned messages, and all of those pinned messages have links to all of these quests. So you can just go over there and click on the first quest and start doing the labs. And apart from that, I also have some FAQs and other questions there. So we'll talk about that later in the Discord channel. So yeah, this is the first track which you have, the cloud engineering part. The second is the machine learning data science. So in this thing, I have to emphasize that this is not like pure science or machine learning. So we don't actually teach you how the different functions work or what the different methods are, or there are no paper implementations in this case. What these quests do is get you familiar with what tools Google offers you. So for example, if you have an idea of you don't have to actually have any knowledge of any of the algorithms. So most of it is configured itself. So for example, if you take an example of dogs versus cat classifier or some any other example, so you just have to know that you just have to know your purpose. Like I have to classify these things, and then you can go about using the services. So there you have for functions like AutoML. So these are the things which train a network on their own. You just give them an input. You just I want this and these things, and they will train a model all on their own and just give you a perfect ready-made model as an API. So the purpose of these quests is not to teach you the machine learning principles, but instead to teach you the tools that you can use in your applications. So and actually most of the developers actually use only APIs in their apps. For example, if you're building a mobile app and you want, say for example, you're building a QR scanner, or you're building some document scanner thing, and you want to read text of the images. So you don't have to actually know what algorithms go behind NLP and how does this thing actually work. You just need to know the API that you want to use and what services you can use inside your app, how to integrate with your app. So this is the only thing which matters to you if you're building an application. So if you talk about that, these quests can tell you what Google Cloud offers and what are different services that you can employ. And if you see the names, you'll have BigQuery and other things. So BigQuery is just like a very huge database, and you can perform different queries on it. And also it has public data sets which you can explore if you want to. Like you should go about exploring these things. It's really fun if you talk about it. And moreover, in the future, as I imagine, like most of the functions of machine learning will be transferred to the cloud, because as you imagine, machine learning requires very heavy computations. So not everybody has such heavy computation at their disposal. So ultimately, everything is moving towards the cloud, is shifting towards the cloud. And apart from like Google Cloud, other providers as well have very attractive options for machine learning. Like they have dedicated libraries which help you get on track with machine learning, and many of them also allow you to learn the concepts as well. So I think you should explore. Yeah, now the skill badges part, really important. So what are skill badges? So remember the quest that we talked about in the previous slide. So whenever you complete a particular quest, you get a skill badge. So the skill badge is what you get when you complete the challenge tab. So every quest that you have will have a challenge tab at the end. The challenge tab actually tests your understanding of the entire quest. So when you're done with the challenge tab, you'll get a skill badge like one of these. And these are really important because you can put it in your resume, you can put it on your LinkedIn, and you can show it off to your recruiters. So because these are a proof that you have understood this industry relevant skills and that you're comfortable using them in a real life environment. So it's really important that you earn your skill badges, and you also put them on your resumes, or not in resumes, on your LinkedIn profiles, wherever you want it. Yeah. So these are just the things which I talked about right now. Get hands-on experience and prove that you have all these industry relevant skills. Now I'll talk about the price that you have in store for you. So if you complete any one of the tracks, like even the cloud engineering track or data science or machine learning track, you'll get a participation certificate from Google, a t-shirt, and a sticker pack. But if you complete both of these tracks, which is likely because we have 15 more days to go, and if you really invest some good hours into it, you can go ahead and, because ultimately you'll be using the skills any now and then. It's not like you think that, okay, I'm not in the machine learning domain right now, so I won't bother with the track. You have credits. The credits will be valid for the maybe up to a year as well, so don't worry about that. But the prices are still in store only till November 5th. So if you have to work on it, you can go ahead and work on it now, because the skills will always stay with you. You can always come back and look at the labs and revise. And moreover, if you have these skills, you'll have new opportunities and new work that you can look into. So if you complete both the tracks, you get 2 t-shirts, you get a participation certificate, of course, a sticker pack plus a laptop pack. So these are things that you get if you complete both of these tracks, which is really fantastic. Yeah, this is what your certificate looks like when you get it. So yeah, sure, it is. And these are just very basic GCP idea. Like whenever you are working on something, what is a project? When you click on the Quick Labs lab, you see a Quick Lab project on the top left corner. So a project is just a grouping of all the services that you're going to use. For example, if you're using a bucket, if you're using a volume storage, if you're using a virtual machine, all of these are logically grouped into a single project. So if you're working on some particular app, you can create a project for it. And all the resources that you're going to use can be linked to that particular project. So you have a better separation between different projects and different resources. And so you can better manage what resources are taking how much of your money and resources. So there's just a basic logical reason. Yeah, these are cloud identity access management. I think there are different labs on this. So if you go over those labs, you understand that you can, restrict access to your project to different people. You can allow certain people to access only certain parts of your project. For example, if somebody is working on the storage part, you can configure the permissions of that particular person to only be able to access the storage part and not the other virtual machine or any other services that you might use. So this really comes in handy when you're managing a project on a team basis. Yeah, and you can also deploy it on different regions around the world. Like you'll have, if your application has most of the users in India, you'll prefer to have applied to have deployed it in India itself, because it will have shorter times and it will have a good user experience. And so these are just basic cool cloud terms which you'll require when you're actually deploying a system to production. So just keep this in mind. Nothing more about that. So yeah, that is about the session. So if you have any questions right now, you can go ahead and ask me in the chat. I'll go over there. And now, once I'm done with the questions, if there are any, I'll go over to one of the labs and we'll see how we go about solving them and what is the approach that I usually take when I do a particular lab. So I'll just go to the chats now and see if there's something that you have to talk about. Yeah, feel free to message in the chats if you can.
Jayesh, go to Q&A section. We have one question there. In the chat, you can see Q&A, right?
Oh, sure. Yeah, I can see it. Will you be able to complete at least one of the 2 tracks in these remaining 15 days? Yeah, so given that each track will have, say, for example, 6 or 7 quests, and each of these quests have maybe 4 or 5 labs, I think you can complete a particular track in 15 days, because what it takes for you is just follow the steps. Because if you have seen a lab, you know that there are a lot of detailed instructions on every line. They also give you commands at your disposal, so you don't have to write the commands yourself as well. So if you really want to complete a track, I don't think that it will take 15 days for you. And moreover, I'll just when I go over the particular lab, I'll show you how to approach it and what is the best way you can take the most out of it. So maybe you'll understand that, yeah, it's easily can be done in 15 days. How important do you think doing certifications is? Yeah. So when it comes to certifications, I personally feel that it's not very important, but it holds importance when you have, say, for example, a very hard test. For example, the certification of Coursera, I don't think hold much value in my case, because most of them can be achieved by taking code off from different websites. So if instead you think about Microsoft certifications, technological certifications, those really have a very hard test. Like you have to go to a center and take the tests. So those tests really do have a lot of value in the industry. So if you have, say, for example, a Microsoft certification or Google certification, so those things really hold a great value when you are showing off to your recruiters. Because, say, for example, you are sitting in an interview and you have a resume and you have some projects. So if you just have your projects, then the interviewer might be skeptical about how much you actually know, because most of the time when you start a project and you just maybe completed only half of it, you just still write it on your resume. So there is no sure way of knowing that you understand the concept properly. So in that case, certification does help. But if you still have internships or other programs under different professors, that also acts as a very at a similar level. So you don't need certifications if you have good internships. But in the absence of that, certification will really help you solidify that you know the particular skill. So yeah, that is important. So in the ML track, they're not teaching ML algorithms, but how to deploy it on cloud. Yeah, they're not teaching you algorithms specifics. For example, they are teaching you algorithms, but like they're not going into the depths. They just tell you that, okay, if you're talking about neural networks, they just give you a very brief understanding of what neural networks are and how it works. But they won't tell you how to configure the parameters and how many layers to use, how many nodes to use. So all of these are not actually covered to Google Cloud itself, because Google Cloud will only offer you services which can, which have all of these things ready. Because most of the time when you imagine, whenever you have to deploy a neural network or something else, you take code from somewhere, right? You don't write a neural network from scratch. You just take it from somewhere. You take the pre-trained parameters from somewhere. So it's the same idea. Google Cloud is taking all of these things and just supplying an end product to you, so you can use it in your application. It is more of a developer-oriented program. So you don't have to be a data science engineer. You have to be just a data engineer. There are two different things. If you are working in data science, you have to work on the different. It's called two different roles are called data scientist, data engineer. So what data scientist does is it discovers algorithms. It goes over different parameters. So the work of a data scientist is to find out the best algorithm for the use case. So for example, if you are in a company and you're a data scientist, you have to find out what algorithm works best for your company and for your use cases. On the other hand, if you're a data engineer, you don't have to worry about the algorithms. The algorithms will be supplied by data scientists. You just have to make sure that you take the algorithm and you deploy it in the most efficient way. So for example, if you do have an algorithm, now what? How do you deploy the neural network? So this is a very good challenge. For example, if you know these parameters are relevant to my model, but how do you actually deploy this model so that your applications can access it everywhere? Like you can use any application, so you'll have to have a very fast and reliable model. So all of these things are handled by data engineers. And what Google Cloud offers in these programs are the things which are specific data engineer roles. So if you do these programs, you'll understand how deployment works, how these things are managed and other things, but not exactly how the algorithms are made. I think that's clear. Yeah, next question. Now, what should one do if he gets stuck with one of the challenge labs? Yeah, that's a good question. So yeah, I'll go over that right now. When I go to the next lab, I'll just show you what to do when you are stuck and whom to reach out to when you have troubles with the labs. Also, a very basic approach. We'll go over that issue. We have been given limited credit. What will happen if someone not able to complete one lab in time and still complete the course? Yeah, you actually don't have limited credits. See, you have 600 credits, right? So as far as my estimation goes, around you require 295 credits to complete both the tracks. So if you are willing to do cloud engineering and machine learning tracks and you do it in one go, you can complete it using only 295 credits. So you have around 305 credits at your disposal. So it's really more than what you want. You can complete the labs twice. So you don't have to worry about that. If you fail in a particular lab, you can do it again if you feel that you missed something. But don't do it before analyzing what your mistakes were. Because most of the time, as I've encountered already in the past few days, is people tend to forget about default values. So for example, if I'm running a cloud function, say for example, So if you have a cloud function, you have to think about what triggers the cloud function, right? So you have to think whether creation of a new object or when you update a new object or delete a new object. So what particular activity should trigger a cloud function? So when you're building the resources, when you're configuring the resources, you should pay attention to all of those fields, because these fields which are something which you can skip and doesn't cross your mind at that particular point of time. And so you fail to recognize what went wrong in your lab. So if you keep on continuing to do your lab without any analysis, you just waste your credits and nothing else. But don't worry about that. We have sufficient credits for that. You don't have to worry about it. Are there any more questions? I'll just wait for a couple of minutes and see if there are more questions, and then we'll go over to the lab. I mean, generally, just it's not like a very big deal if you try to learn these things on your own. Like even if you take a lot of time to complete a lab, it doesn't really matter, because these skills are what you're going to use in your own application. Say, for example, you're going to a hackathon or you're building something on your own, you're just experimenting with different stuff. So having cloud benefits with you is like really empowers you to build better applications. For example, if you're building a machine learning based mobile application, if you build a simple application, it doesn't hold much value, because building a mobile application is really not a very big deal right now. But if you're building an application, what differentiates your app from other apps is the things that you put into it, the features, right? So if you have, say, for example, a very smart ML feature into your app, because unless you go over these things, you won't realize what are the possibilities that you can achieve. For example, if I am familiar with cognitive services, if I'm familiar with the AI services on Google Cloud, I will know that I can read text from an image, I can read subtitles from a video. All these things are possible to go with the cloud services. So when I know these things, only then can I have new ideas to develop them into my app. So you just need to explore more, and you can get more ideas for your app. So it doesn't it doesn't hurt to build applications, right? You can just go over and just employ any of the API services you want and build a small application. Always add to your resume. And it'll also show that you have very explorative and adventurous state of mind. Okay, so I see there are no more questions now. Yeah, so I'll go over to one of the labs quickly. Let's see. I'll first go to Discord and I'll show you the channel again. Okay, as it loads, I'll go to quick labs. Yeah, so maybe I'll go to this particular lab. Correct. So say, for example, you open a particular quest. This is the second quest, normally in the cloud track. Perform foundation project tasks. So how do you go about doing this? Say I'll choose cloud functions. I'll go over to this particular lab. No, it's pretty small, not this one. This is 15 minutes. Won't be worth it. Yeah, pops up. Pops up is nice. Yeah, so pops up. So, say for example, you're a complete beginner. You have no idea what pops up is, and you want to start learning it. So you'll see the timer is 30 minutes. So if you start the lab right away, you'll have to run against time. Like you have to complete all these requirements. You'll have to think that, okay, my credits are being wasted on this. I have to complete really quick. So don't start the lab as soon as you land on the page. You first go over to this part, setting up PubSub. You read the entire lab first before starting the lab. That's what I do. So whenever I encounter a new lab which I know little about, I just first go over the entire lab contents, understand what's going on. I form a picture in my mind, a workflow kind of thing. Like first I'll do this. So because if you just keep on parroting whatever's written here, it won't allow you to learn much. So first what I do is I just go over the entire detailed scenario. So first, if I look at PubSub, I'll see that what is done there. We have to set up PubSub. You have to create topic. Now I don't know what a PubSub is. So what do I do in this case? I'll just open a new tab and I'll search what PubSub is. I'll just click on PubSub, and there is a lot of documentation there. So you just click on what is PubSub and open up a new different publication. Now, if you see, there are a lot of things that you can learn from it. There's a video as well. So I'll just go over this video. I'll go over the quick start. I'll go over different functions and understand what a topic actually is before I implement one. Because in the lab itself, it doesn't tell you what a topic is. It just tells you where the topic is found and how do you create one. But if you want to really understand what PubSub is, what topics are, you should always, research about every particular topic. So if you start a lab now, you won't be able to research very thoroughly because you always think that, okay, the time is running out, I have to quickly complete the lab. So that is not the approach you should be taking. You should first go over the entire lab, think about the topics and understand each of them properly. Because if you don't know what a topic is, the lab doesn't really matter much. Because even if you complete the lab, there's the skill which you gained is not up to the mark. Because even if you get the skill badge, if somebody asks you about this particular topic thing, you'll just fail at it. So there's no point in it. So you just go over to the PubSub, you read about this, you read about what a topic is, and if you require, go to other different services, go to YouTube, find new videos on it. It's just a basic idea. So now I know what a topic is. Now I'll go ahead. I'll just think about creating a topic and what these things are. So I'll keep on moving ahead. I'll first read the entire lab, understand it completely, and then when I start the lab, I won't visit this page again, unless for commands. If you have very specific command line commands, so I'll just go back and just copy paste the commands. But apart from that, I'll just look at what are the things I want to do here. Like I want to create a PubSub topic and I want to add a subscription. These are the two things which I have to do now. So first, I'll read this entire lab on my own. I'll find out what the things are, how the things work, and then I'll just start the lab and keep in mind these two objectives which I have to fulfill. So when I have these two objectives in mind, I'll go over to the lab and explore the entire console myself. Because you see, whole console has a lot of different functions. So it's really interesting to look at what other things. Don't just be restricted by the contents of the lab. When you're done with your lab, you can also explore the different tabs. You don't have to create resources because that might get your account blocked. Because normally when you deploy a lot of things which exceed the quota for the particular lab, they block your account. So you just keep that in mind. You just go over to different tabs and see what other tabs are, learn about them. So this is how you actually explore, because going by a very specific track will not get you too far. Unless you're willing to explore and watch territories, you won't understand the entire scenario itself, because it's very huge. This entire list doesn't end anywhere. So you can always go ahead and research on new topics. So yeah, this is a basic idea of how it works. Say for example, I get stuck at a particular part. Like if I take for example the second objective, check my progress. Okay, I'm not started the lab right now. I just started. Yeah. So I'll start my lab. So now, say for example, add subscription. Yeah. So if you click on this particular thing, you'll get a hint of where I'm feeling right now. So the message says, please create a PubSub topic. So I've not even created a topic yet. So whenever you, say for example, go over any particular check my progress bar and you click on it and it shows a red. So you don't have to, be clueless. You can always click on this, get a hint from here that where you are going wrong. This is the first troubleshooting way, first troubleshooting step you should take in order to identify what your problem is. Say for example, even after looking at your message, you don't have a very clear understanding of what went wrong. In that case, you can do two things. First of all, if you are somewhat experienced with Google Cloud, you can go take a look at the logs. For example, every service that you have, even a virtual machine, say a cloud function, all of these things have a log features. So you can always view the logs of. So logs always have every message that goes on with the application. So it has updates about what happened to your instance and what resource went wrong, what are the errors. So all of this will be registered in the logs itself. So whenever you click the three ellipses, three dots on the side of any resource, you'll get the option to see a log. So when you see the log, you'll understand that, okay, maybe this particular thing is the culprit for my application being a failure. So that is the second, that's the first thing which you can do after you check the message. And say, for example, even after looking at the logs, you don't have an idea of what the problem is, then you can take a screenshot of that log and share it in our Discord channel. Because if you share it in our Discord channel, then a lot of people can look at your message. Maybe somebody has already went through that particular problem and they can help you with it. If you contact me directly, only I will be able to help. But if you reach on the Discord channel, there are a lot of people who are willing to help you. So just keep that in mind. And whenever you're asking for help, you should first specify the logs, that these are logs which I see, and you should specify what steps you took as a troubleshooting. Just if it fails, just don't go out in the Discord channel without trying anything. Because if you do that, it'll make a very bad habit out of it. Like whenever you fail an application, you just go over to someone to ask for help. So that should not be your first step. Your first step should be analyzing what actually went wrong. Because if you're asking somebody for help, that particular person is also going to do the same steps. So if you ask me for help, I ask you to show me the logs. I ask you to go over some troubleshooting steps. So those are things which I do myself, right? So you can do this on your own as well. So if you do this, you'll understand how applications actually work, and you'll also be able to debug more serious bugs later in your future when you're working on big applications. So whenever you have a problem, look at the message. If your message doesn't give you a particular hint, look at the logs. If the logs don't help you at all, then you can approach the Discord channel, mention whatever you did, like these are the steps I took, these are the things I went over again, these are the parameters I looked after, and even after that I'm not able to understand these logs. What do these mean? Can somebody help me out? In that case, the people who are going to help you will also have a very good understanding of what your problem actually is. So that is a way you should, that is the approach you should take when you're solving any particular problem. I hope that is clear. If you have any doubts regarding how to approach a lab, you can ask it to the Q&A now. Like I think I've covered the basic understanding of how to approach labs. If you have any doubts, please go ahead. I just wanted the Q&A right now. Yeah, that is pretty much. I'd like to mention as well that even after the program ends, like even the facilitator programs end, if you are really interested in pursuing cloud technologies, you should sign up with different services. For example, Microsoft Azure also offers you $200 in credits if you sign up as a student. So you'll get that as well. So most of these services have, like Microsoft Azure, Google Cloud, all of them have very similar services on different names. So even if you learn GCP, it doesn't really matter. You can switch to Azure anytime you want. You can switch to AWS anytime you want. They just have different names, but the purpose is entirely the same. You will have infrastructure, you'll have a platform, you'll have a software as a service. So the things that you learn in this particular program are not bound to GCP itself. I want you to understand that. So it is no harm in doing all of these labs. So you should always keep that in mind. So it always help you in future projects, nothing else. Apart from that, I don't see any questions here. Cool. Let me just think about if I missed any particular point. Asha, do you have something to ask, or do you think if I missed on something?
No, so far so good. The major query that we
Okay.
often had from students was about the certifications that you handled very well. So it's clear actually.
Okay. Okay, sure. Yeah, there's a question now. Is it fine if we don't fully understand what exactly we do, like load balances, continuous list? Yeah, exactly. That is what I'm talking about. So if you don't understand what load balancers are, you should probably go over YouTube to look at some videos. So you should. What I like best is the documentation. So I'll just go over a very quick example. Let's see if I don't understand what load balancers are, what I'll do. I'll search load balancers. Simple as that. Now I'll go over. So these are the ads. Don't worry about that. So I'll look at some very good, resources. So Nginx, I know, is a very good website. It's a very good service. So I'll just open this particular tab. DigitalOcean is a really good resource. Like I recommend DigitalOcean wholly, because if you go to the documentation of DigitalOcean, you'll have very detailed, articles on everything. If you want to look about SSH, if you want to learn about any particular thing, just go over to documentation of DigitalOcean and you'll find a lot of things. This is actually the product page of the load balancer. Is not what I'm looking for. I'll go over to the document page, docs. And now you see there are so many things to explore. Like just it should excite you at the very first sight. So if I look at here, there are images, domain. So there you see the load balancer under networking. So you know that load balancer is a part of networking. So this is the first clue. I click on load balancers now. Yeah. So you see there are a lot of resources right now. So you can see you can have a quick start, you can have overview, you can have how to resources. I'll click on resources. I'll see what resources are available for load balancers. I'll go over to this part. Let me see. Yeah, there is nothing which I can use. Let me see what how to is. So these are the steps which I usually take in understanding what different things are. So if you look at it, the screen now, there are not good resources about it because it mostly deals with the product itself. So this is not much helpful. I'll go back. I'll search for what are load balancers. Yeah. Yeah, so Swift is also a very nice part. And also reference Wikipedia. Now I'll go to Nginx. Now you see you have a very detailed article, you have a diagram, you also have a video, which is a really good thing. So you can also, you can go over all these things you're on your own, understand what these things are. And even if you say if you read about a term which you don't understand, so you can always search for the term again. So it usually forms a chain of it. For example, the thing is that all these terms are really broad. So you can't really understand all of it in one go. If you are learning about load balancers, don't expect to learn everything in just one go. You'll learn about a few things and then you'll explore that there are a lot many things that you don't know about yet. So if you know just one term load balancers now, after you start reading about it, you will see there are a lot of terms which you don't know about. Like load balancing is the first step. Then you see what different hashing are, what different algorithms are, and all the different things which you are related here. So you should keep on exploring this until you have a very good understanding of what you're actually going to do. So if you don't understand what load balancers are doing and what their purpose is, I don't think there is a lot of value in completing the lab itself. Because the purpose of the lab is to get you familiar with how to deploy it on Google Cloud and not to make you understand what a load balancer actually is. So if you want to understand what these things actually are, you have to go on your own to research about it. So the quests in the labs only deal with how you can create these things on Google Cloud and how you can use them on Google Cloud. It is very specific to that particular user case. But if you want to understand the entire thing, which I think you should go look on the website. Like this is one of the things Citrix. So when you look at these diagrams and look on these different methods, I think you'll have a good idea. Even after going through all of those, you don't have a very good understanding, and always ask in Discord channel. I'll maybe explain it on my own terms. I'll get on a call with you. Means we can explore different things when you talk about that. So yeah, the answer to that question is you should go over every particular thing on your own, understand it, only then implement it. Like containers, clusters, I think we'll organize a session on that really soon, because I don't think you can quite effectively learn the entire containers if you go about on your own. Because if you start learning them on your own, it will take you a lot of time, because you won't know where to start, what sources to attend to. So I have learned that over a good period of time, so I have a good understanding of what different sources might be useful to you. So I think a session on that would be helpful. So we'll get back to you on that. But yeah, any small things like load balancers pops up and all those things you should understand on your own, because ultimately you're going to use them in your own application. So if you don't understand, there's no point in completing the lab. I think that answers the question. Yeah, any more questions? And more, I think you should keep in mind that asking questions on Discord is a really good thing. You should not shy away from asking questions, because if you don't understand whatever it means, just shoot a question on Discord. We're all there to help you, right? There are a lot of people there. There are a lot of people more experienced than you who can actually help people there. So there is no way you should be afraid of asking questions on Discord. That is one of the points I want to highlight here. And also, I told you how to particularly ask a question, because asking a question which is not in the proper way will usually not attract as many replies as a good question will. So if your question is really nice, then people will be tempted to reply to it. But if you just post a very vague that, okay, this test case is not working, so people might not be too tempted to answer your question. But if you go over the detailed steps and you go over the logs, so then it will be easier for people to help you, right? This is a basic idea of how it goes. Let me see. Okay, so I see no more questions. That's nice. Asha, what do you think? What shall we do now? Do we have something else?
I don't think so. If they don't have any questions, maybe they can reach out to you via Discord or via me whenever they find anything.
Yeah, sure. Yeah. You can always do that. Yeah, you can always reach out on Discord, and it'll be preferable if you do it on the channel itself. But you can also DM me. That's the problem with that. Any of those things work. And let me see if I have something else to say. Nope. I usually talk a lot. You must have understood it by now. So yeah, it's pretty much it. So maybe I hope I was able to transfer some of the enthusiasm about cloud. Like I haven't covered like a very huge portion of it. I just touched the surface, and I just I think I didn't do justice. If we had a lot of time, would have gone over a lot of different things. It would take hours. But I know that you'll get bored. You'll get you would lose interest in this. So I'll just allow you to explore it on your own and not through a particular session. I prefer sessions to be just short, like 1 hour, maybe 1 hour 30 minutes, just to give you a very spark of what these things are, and then you can go about it on your own to understand different things on your own. But this is the approach I like taking actually. Yeah, see, there are no more questions now, so yeah, maybe we can, actually, do we need to take a screenshot or something? I think we should maybe take a screenshot, I guess.
We don't need to post it actually anywhere. They don't have that requirement. And
okay, sure. Okay, sure. Okay, then maybe just look over the attendees. Cool. I'll just keep these things in mind.
So thanks, Jayesh, for a great session.
Yeah, thank you, Asha, for hosting this session. Thank you, host. Okay, so we'll end the session now. Thank you guys for joining.